Solving a 2 by 2 system by elimination. So let's look at our first example, which is a system with equation 3x plus 2y equals negative 2 and 5x minus y equals 27. Let's call the first one equation 1 and the second one equation 2. So our first step is to choose which variable to eliminate. We can make our lives a little bit easier if one of the variables has a coefficient of 1 or negative 1. And if it does, then we should choose that one to eliminate it. So here in the second equation, y has a coefficient of negative 1. So we are going to choose y to eliminate. So then multiply the equation with the variable with a coefficient of 1 or negative 1 by the coefficient of that variable in the other equation. If it were a positive y, we would have multiplied it by negative 2. Here we're going to multiply it by positive 2. You want the variable to have opposite signs. So our first equation stays the same, 3x plus 2y equals negative 2. And we're going to multiply this second equation by the 2. And so I end up with 3x plus 2y equals negative 2. Again, the first equation stays the same. Second equation becomes 10x minus 2y equals 54. I just multiplied everything by 2. Step 3. Add the two equations and solve. Okay, so 3x plus 10x is 13x. 2y minus 2y equals 0. It cancels out. Negative 2 plus 54 equals 52. If a variable did not cancel out, you did something wrong. Now I'm going to solve by dividing both sides by 13. X equals 4. So we're halfway there. We're halfway done with solving our system. We have our x value. Now we need to find our y value. Step 4. Substitute the value from step 3 back into either equation. Okay, so I'll choose the equation 5x minus y equals 27, but it could have been either one. I'm going to substitute 4 in for x. So 5 times 4 minus y equals 27. 20 minus y equals 27. Subtract 20 from both sides. Negative y equals 7. Divide both sides by negative 1. Y equals negative 7. So our answer will, of course, be in the form x comma y. And our solution here is 4 comma negative 7. We can check again by substituting 4 in for x and negative 7 in for y into both equations and seeing if the equations are true. So our first equation, 3x plus 2y equals negative 2. Substitute 4 in for x, negative 7 in for y. Does 3 times 4 plus 2 times negative 7 equal negative 2? 12 minus 14, does that equal negative 2? Yes, it does, so it checks out. Equation 2 was 5x minus y equals 27. Substitute in 4 for x and negative 7 for y. Does 5 times 4 minus negative 7 equal 27? 20 plus 7, does that equal 27? Yes, it does, so it checks out in both equations. Okay, so let's look at an example where we don't have a coefficient of 1 or negative 1. So again, we need to choose a variable to eliminate. So here we can eliminate y. We could eliminate x just as easily. I chose the one where both of them have smaller coefficients. I'm going to label the first equation 1, the second equation 2, just for reference. Then multiply both equations by a number so the chosen variable will have the same number coefficient, but opposite signs. I want one to be positive and one to be negative. Okay, so these are my original equations. I chose y to eliminate. I'm going to multiply the first equation by 2 and the second equation by -3. So my first equation, when I distribute the 2, becomes 10x plus 6y equals 24. The second equation becomes negative 21x minus 6y equals negative 57. Okay, step 3, add the equations together and solve. 10x minus 21x is negative 11x. 6y minus 6y cancels out. 24 minus 57 equals negative 33. Again, if a variable did not cancel out and disappear, you did something wrong. Okay, continue solving by dividing both sides by negative 11. X equals 3. Again, we're halfway there. Now we just need to find the y value. Step 4. Substitute the answer in step 3 into either original equation and solve. Okay, I chose the first equation, but you could have chosen the second one just as easily. 5x plus 3y equals 12. Let's substitute 3 in for x. So 5 times 3 plus 3y equals 12. Or 15 plus 3y equals 12. Subtract 15 from both sides. 3y equals negative 3. Divide both sides by 3. Y equals negative 1. Again, our answer is in the form x comma y. So our solution is 3 comma negative 1. Checking. So 5x plus 3y equals 12. Does 5 times 3 plus 3 times negative 1 equal 12? 15 minus 3, does that equal 12? Yes, it does. And in 7x plus 2y equals 19, does 7 times 3 plus 2 times negative 1 equal 19? Does 21 minus 2 equal 19? Yes, it does. So the solution checks out.